Okay, welcome to our second tutorial. The last tutorial we did something very simple, a basic introduction to Proteus, and today we are going to be carrying out a new test. Today we are going to be playing with measuring instruments. Okay, let's dive right in. I'm going to name my project today. I'm going to call it test 2. Test 2. Okay, like normal, I'll maintain everything as default. Okay. Today we are going to be testing if actually it's theoretically proven that resistors in series have the same current. So we are going to try to see if it's actually practically true. Okay, so what we're needing today, let's go to component, electronic components. We need resistors. Okay. Resistors are already out. Okay, let's take this resistor and we take the first case. You double click and it appears in your workspace. Okay, next we need a source, a power source. So let's take a battery. No, let's take a cell. Precisely an active cell. Okay, let's put our cell in the circuit. Place it there. And we need our resistor. Okay, place it there. To test, actually we need at least 2 resistors to actually test their potential, to test if the current flowing through the first will be equal to what's flowing through the second, and should be equal to what the load is actually giving out as current. Okay, putting number 2 somewhere here. Rotates. Okay, now we need an ammeter. We measure current using an ammeter. So for this case, as it's a DC source, which is a battery, I'm going to take, you go to virtual instruments and you click. We are working with DC, so we're going to take a DC ammeter. I'm going to place one ammeter before my first resistor, the second ammeter after my first resistor. You should take note, in DC polarity does matter. And I'll put the third after the second resistor. Okay, done. Now let's do our connection. And this is the first circuit. Let's build a second circuit, of which we are going to connect 2 resistors in parallel and see if the current is going to be changing, and we try also varying the values of resistors and see how it actually affects the current. Okay, we build the second circuit. Okay, we take another ammeter, precisely DC ammeter. This ammeter before the load will measure the total circuit current, and an ammeter across R3 will measure the current of R3. ammeter before R4. Okay. Yep. Okay, all the resistors having the same value. We'll do the first simulation with the same value for all the resistors. Let's simulate and see. Okay, if you've noticed, almost all the resistors are showing 0. The reason is because the resistance is very high. Resistance is the opposition of current in a circuit. So due to the fact that the resistance in the circuit they are above a certain value, so the circuit current is negligible, is approximately 0, because it cannot go around the circuit. So let's see what's going to happen if we reduce all our resistance to 100 ohms and increase our voltage to 15 volts and see the value of the current in the circuit. I'm going to stop simulation. Okay, the first resistor, I'm going to move the K. It means I'm going down to ohms. It's no longer 100,000, but it's now 100 ohms. Okay, I'm done. Now let's simulate once more. The value of the batteries I've not edited. Just move that decimal point, it goes to 15. Okay, let's simulate once more and see our values. If you notice, let's first of all concentrate on the series circuit. I'm going to zoom in. If you look at the value, the load current is actually a current flowing through R1 and it's the same current flowing through R2. Okay, now let's focus on the power circuit. Because R3 is equal to R4, they're having the same value they're having the same current flowing through the both of them. And the total current is just a division of what each branch is taking. So let's see what will happen if we add R3 by 50%. If you notice in the power circuit, it's now calling a different current, but now the proportion of the currents is different. Where the resistance is greater, it calls lesser current compared to where the resistance is lesser. So okay guys, this is what I was going to show you today based on current. Now you've seen how current behaves in the power circuit and this way it behaves in the series circuit. So the next video we'll be talking about how voltage behaves in a power circuit and how voltage behaves in a series circuit. Okay, see you guys. Hang on. See you guys in the next video. Bye bye.